So in today's lecture, we're going to spend some time talking about X-linked recessive phenotypes. And I'm going to explain what I mean, but you should hopefully know by now that genetic females have two X chromosomes in Homo sapiens, in humans, you and me. And genetic males have an X chromosome and a Y chromosome. And we're going to discuss what that means. But so we're talking about X-linked recessive phenotypes. And you should know you have 22 pairs of autosomes. Okay, you have 22 pairs of chromosomes that have nothing to do with your sex. But you have one set of chromosomes that are sex determining. So 22 pairs of autosomes, one pair of sex chromosomes. Here are our sex chromosomes here. And you'll notice, or the first thing you should notice anyway, is that the Y chromosome is smaller than X chromosome. And the reason that this is important, or the reason that we see some differences here, is that basically there is no homologous portion of the Y chromosome for certain genes. And so let's say the X chromosome has genes A, B, and C. There's nothing corresponding to that on the Y chromosome. There's a whole section that's just kind of not there. And so because men are running around with this puny little Y chromosome, we wind up being more susceptible to certain conditions. And let's talk about the genetics of Y. So let's say we have a male who is a carrier for an X-linked trait, reproduces with a female who is heterozygous for an X-linked trait. I kind of misspoke here, because if you're a carrier for an X-linked trait and you're a male, that means you have it. Anyway, we have here the female is X with a 1 and an X with a 0. This chromosome does not have this condition. This chromosome does have this condition. And I'm saying condition, which might seem like slightly medical, but it could be any number of things, okay? This chromosome is not a carrier for the phenotype or for the allele that expresses it. The male over here has an X with a 1, meaning this chromosome does express this condition. He does have the condition. And then a Y. Notice there's no number by the Y because the Y doesn't have any allele. Like I showed previously, there's nothing there. And so it doesn't get a 1 or a 0 because it doesn't make any sense. There's just nothing there to compensate. So what kind of gametes can these folks make? Let's look at that. The female can make an X1 egg and an X0 egg. The male can make an X1 sperm and a Y. And let's run the Punnett square to see what their offspring might look like. And you can see here that half the daughters and half the sons are getting this condition. Okay, but we're going to discuss what happens if the male is not a carrier and the female is a carrier. And we're going to see why males are more susceptible. So let's think about a scenario where a male who does not have a condition gets together with a woman who does have the condition, and it's recessive. So remember, she needs to be homozygous recessive, or she needs to have both alleles expressing this gene. So let's see what our Punnett square looks like here. We have the female here on the left, we have the male here on top, and you should notice that none of the daughters have the condition because they have this X0. None of the daughters have the condition, but every single son that this couple has will wind up with the condition. Let's look at a Punnett square for color blindness. So here we have a female who is a carrier. She has one allele, one colorblind allele, and she has one allele that is not colorblind. And so this female, because this is a recessive trait, does not wind up being colorblind. Here we have a male who has one normal allele and a Y chromosome. This male is not colorblind. Let's see what happens when we look at their offspring. So we have one of their daughters has two normal alleles. She is not a carrier and she is not colorblind. Their other daughter has one colorblind allele. So she, like her mom, not colorblind, but is still a carrier. Down here, one of their sons has normal vision because he has one big B and a Y chromosome. But their other son winds up with one colorblind allele and a Y chromosome. And so half of their sons wind up being colorblind. And half their daughters wind up being carriers, but still having normal vision. And so if you ever meet a female who is colorblind, I can guarantee you that her dad is colorblind, for one thing, and I can guarantee you that her mother was a carrier. So these kinds of conditions, men wind up being much more susceptible to them because, again, they don't have that extra region of their Y chromosome to compensate for these kinds of conditions. So I'm probably going to ask you about this kind of thing on a quiz or a test.